Doing good. I'm doing good. Let me put my Hey, Wade, how you doing, my friend? Let's go to the just chatting cam here. Hello. Hello, hello, hello. How you guys doing? You both doing good? I'm doing good. I'm doing good, Aiken. Good to see you again, my friend. Here for another rip-roaring week of mathematics. Cool, Dad. How you doing, my dude? You doing very good? Good. I'm doing wonderful, wonderful. Had a nice, relaxing weekend. Got a few things to do this week, but shouldn't be anything too crazy. But hopefully you had a wonderful weekend as well. Glad everybody's coming out here a little bit early, so I can't argue with that. Maybe Mondays are a little bit more motivational. I don't know. How am I supposed to argue with that? You've been streaming. You've been streaming a lot. You have 10 followers. I'm like 10 followers from getting affiliate. Nice, dude. What are you streaming, Cool Dad? Did you hear how they released a fake final chapter on Attack on Titan? Oh, did they really? I had not heard of that. That's pretty bad. Super Mario. Okay. Very nice. Very nice. It's a very healthy community, Super Mario Maker 2. Very nice. Look at that. I like. Hey, look. I will do support other streamers, small streamers, big streamers. Mostly small streamers though. Definitely. I think if you offer something positive to the community, why not? Right? Nothing wrong with that. I try to stream other things, and I don't get the views that Super Mario Maker streams to do so. Okay. Well, that's just one thing. Again, I'm glad you're trying other different things here. You know, it doesn't have to be just limited to one thing. That's why I make my streams like, hey, this is for classes, but if anybody wants to come and watch me do something else, that's fine. Whatever the case may be. But you know, just make it your own. Essentially, at the end of the day, don't let necessarily viewers dictate what you should or shouldn't do. Just have fun with it. That's all. As a lot of people say, keep your day job. Me too. I keep my day job, but this is my job. Yeah, so like this is my job, so that's why that's why I'm streaming here. But if I were to stream like more casual, then I just do whatever, and just be like, all right, cool, let's just do whatever, and whether the people come out, it's cool. Ziggy, how you doing? Good morning to you. Good morning, Ziggy. Good morning. Hey, Anna. Good morning to you. Hello. How are you doing? I'm doing great. I'm doing great, Anna. How are you doing this morning? I hope you're doing good, Anna. Ziggy, I hope you're doing good as well. No, we were having a little bit of fun last time, so. You think it'll be a good day? Wonderful. I'm hoping that it'll be a good day. Definitely. Let's not think. Let's do it. Let's make it a good day, right? Let's not just think it. Let's make it happen. Let's put it into existence. Good days all around. Good morning, Megan. How are you? I'm doing great. I'm doing great. It's a good morning here today. It's wonderful. Look at it. You know why it's wonderful? Because all of you have come to me early here. It's because I missed class last one day because I went to get. Hey, that's perfectly fine, Ziggy. Hey, man, that's your health. You went to get your first vaccine, man. I'm proud of you. Great job. You got your first vaccine, and 1 month from last Wednesday, you'll get your second one. You'll be fully vaccinated and ready to go. So, absolutely, I support things like that, and I'm glad you're up on up to date on those sort of things. Absolutely, 100%. You know what I think we gotta do? I think I know what I want to do. Let's see if I have it here. Go. There it is. There it is. Oh my gosh. Second vaccine, yeah. So it should be later in the month. Yeah, absolutely makes sense. My second vaccine was like a month later, so it was like 4 weeks. But I think depending on manufacturer, it could be 3 or 4 weeks after you get your first initial dose. So it makes sense to be like close to the end of the month. Oh, you're updating. Oh, I didn't realize you're updating. They got the Pfizer? Yeah, so I think the Pfizer vaccine was like 3 weeks, so yeah, that makes sense. This week I gotta do one thing this week that's very important. I gotta do taxes this week. Boo. Boo, my taxes are gonna smell so bad this year. And I have this mound of paper I'm gonna give to my guy, be like, "Here, go do it." Yeah, don't forget, if you haven't done your taxes yet, one thing to understand is that the tax due date has been extended like a month. I think it's like mid-May or maybe end of May, and they got extended out too. So if you haven't done that yet, yeah, it's not too late. So April 15th is not the date this year. Pull up just a different kind of vaccinations. Yeah, I could do that. Absolutely. Let's see here. Hmm. It depends what kind of stats you want there, my friend. I could tell you some. Uh, yeah, I heard Johnson Johnson was having issues. They had about 73% efficacy rates. Actually, let me move it over to my. Let's go by efficacy rate. I don't want to go by the Philippines. So here we go. Let's see here. Yeah, so this is like the these are the ones that you see here on the screen. Right onto the right here. So 95% for the Pfizer one, 94 for Moderna, which was revised up to 95. There isn't concrete proof about the Russian vaccine. The Novavax vaccine is about 90%. The AstraZeneca was about 70 to 75%. And then Johnson Johnson was 66 to about 73%, I believe. I don't know much about the Chinese one, so that one's efficacy rate is a little bit different. You've been looking for your laptop? Oh no. So yeah, there have been, of course, reports and stuff about certain vaccines, but I'm just gonna stick with like the Pfizer or Moderna ones. Those seem to be the most reliable. So that's kind of like my thing. Yeah, I wanted to do something. This. Come out with a song. All right. Uh, there we go. To my main screen here. There we go. Yeah, it's a supply chain thing. Absolutely. I gonna be? There we go. Yeah, I got it. That took a while. You guys want to play some marbles? Want to play some marbles? I'll play one game of marbles before class starts. One or two. One or two races. We could race. That's fine. I'm gonna pick a random course here. This is Marbles on Stream, where we can play marbles directly here on Twitch. You don't have to buy any software or nothing. All you gotta do is just type in something and you'll be automatically entered. Let's just do some random stuff here. We'll race with some participants. We'll go 25 here, just in case. Alright, all you gotta do in this case is hit exclamation mark and play. So hit exclamation mark play in order to get your marble to show up here on screen. For all the marbles, baby. So anyone can enter at any time, absolutely 100%. There you go, there you go. Anybody else would like to play some marbles before we start class? Exclamation mark play if you would like to play. Alright, I'll give it 5 more seconds and then we'll go. Oh, there you go, Kristen. Very nice. I'll give it another 5-10 more seconds here. Let's do it. Alright, let's see who wins. This is for all the marbles, ladies and gentlemen. All of them. Let's do it. Snow globe time, baby. Ooh, Ziggy out on top, followed by Megan. Ooh, this one's gonna be pretty close. It's gonna be mine, indeed. Alright, we have Wade in... Wade finally coming out of the chute. There you go. Alright, let's see who's coming first. Looks like it's me in first. Ooh, I've decided to overtake the rest of the field. Haha, you scrubs. Uh-oh, I decided to give it back to Ziggy, maybe? Ooh, Ziggy in first, Anna in second. I'm in third, Kristen in fourth. Cool Dad is stuck behind the pack. Oh no. Wade's starting to make a comeback here. We're going all the way down. Let's see anybody who can make it through this area here. Ooh, Ziggy makes it with ease. Ooh. Hopefully we can get through this little area. Does Ziggy's marble get through? Indeed it does. Ziggy taking the commanding me, but going through the ringer next. Ooh, this one's going to be close. Cool Dad has decided to take the bottom route for sheer ease of use. Maybe that will help him actually start catching up. Ooh, Ziggy going all the way around. Cool Dad's like, ooh, you know what? I'm going to take advantage of being disadvantaged, and I'm going to take advantage. So there you go. Cool Dad is stuck in the snowflake, but he has made it out with a relative ease. Ooh, Cool Dad way in the lead now as everybody's stuck in the whirling machine of death. But Cool Dad doing absolute wonders out here, ladies and gentlemen. Cool Dad going all the way. Can he make it to the finish through the funnel? Oh, it's starting to hang up here just a little bit. Ooh, other marbles starting to catch up now. Uh-oh. Uh-oh. All Cool Dad had to do was make it through the funnel. Oh, no. I'm dead last. Oh, boy. I'm dead last, dead ass. All right. Who's going to get through the funnel first? That's Cool Dad. Yes! Winner is Cool Dad. Yeah, boy. Second is going to be Ziggy. Ziggy in second. Who's going to get third here? I think I'm dead last, so it's going to be a while before I make it there. Everybody's circling the drain. Everybody's circling the drain, but Kristen comes in third. All right. Kristen comes in third here. We have Anna in fourth, Megan in fifth. Ooh, I came in sixth. And for whatever reason, Wade is still circling the funnel. Not sure how long it's going to take you to get into where the marble needs to go. Oh, there he goes. It finally goes, makes it. Finally, we have our winner here. Cool Dad with the victory. Congratulations. Cool Dad first, Ziggy second, Kristen third, Anna fourth, Megan fifth, myself in sixth, and seventh is Wade. Yes, indeed. All right. Very nicely done. Very nicely done. All right. Excellent job, everybody. Good work. You all did. How did I overtake you? I rigged it. Nothing is rigged. Yes, Siggy, nothing is rigged. There's no rigging here, I swear. I swear, there's no rigging here. All right. I don't rig a single thing. All right. Oh my goodness. I like how he just immediately gets in last. Like, no, everything. All right. All right, ladies and gentlemen. All right. We're going to get going here today with the new stuff. Oh boy. We got some mathematics to do, so hopefully we'll get this stuff done and dusted out of the way, and then we'll be good to go. So making our way forward here. We got so much time to go. Oh my gosh. It's ridiculous. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. I'll finish. All right. In any case. All right. Do this. Let's do some intros here, and we'll get started. All right. All right. Let's do intros. Okay, let's get started today. Welcome back to Monday. Hopefully, a nice weekend. All right. So today, everybody, we are going to be continuing to move on here in Chapter 10, doing hypothesis testing. I mean, who doesn't like hypothesis? Kind of an important thing. It's kind of a thing, rather important thing. But last time we talked about the basics of hypothesis testing. We laid down the foundational groundwork for understanding hypothesis testing. Now today we're actually doing an actual hypothesis test in a particular, from a particular perspective, I guess the best way to put it. All right. So in a particular way. All right. In any case, let's get to it here. Let's get to it here. Let's get going. And let's see exactly what's going on here. All right. So just to give a little bit of recap here from last time on Wednesday, we talked about level of significance. We talked about how we have only two conclusions here for hypothesis testing. We talked about left tail, right tail, two tail kind of tests. We talked about how to kind of set up those kind of problems based on the wording of the question. Now today, we're going to actually be applying it to actual word problems. All right, so we're going to start here on the first question, which is, this is number 8, but you might have a question, section 10.2 may be number 1 on your handout. In any case, it'll be the same thing. So the first question here from section 10.2 says, what assumptions must we make to do a hypothesis test for a population proportion? All right, oh, by the way, totally forgot before we get going here. I apologize. Does anybody have any questions from last week? Any questions from last week? I totally forgot to ask that, but I guess I'll just ask it now. Any questions from last week before we move forward? Is the exam this week? No. The exam is not this week. Definitely not. The exam will be announced after we finish chapter 4. So once we finish chapter 4 there, Megan, then the exam will be announced. So, but you would definitely know if I announced an exam, by the way, as I would send you emails and stuff like that. You have a lot of exams this week? Well, not in this class. So I think you'll be just fine. I think you'll be just fine in terms of studying for your other classes. You don't have to worry about me. and my exam. So I try not to make math completely miserable in some regards. All right. Anybody else have any other questions before we move forward? We're gonna go ahead and talk about this part here. Hey, Cheska. Good morning to you. Good to see you, Cheska. All right. So let's take a look at this first question here. What assumptions must we make to do a hypothesis test for a population proportion? Well, first of all, to do a population proportion here, all right, we have to have a simple random sample or data from a randomized experiment. All right, so for us to do anything here with the population proportion, remember, population proportion here is just basically saying, hey, I'm going to ask a certain question. I'm going to have a number of people who say yes to maybe that particular question or whatever answer that there is for that question that says, yeah, I like brand A, or no, I don't like brand A, whatever the case may be. All right, we're going to do hypothesis test over things like that. Now, it has to be a simple random sample or a randomized sample, essentially. Letter B, something that we took away from a previous chapter that is still holds true is that NP times 1 minus P has to be bigger than or equal to 10. So you have to have a large enough sample size in order to satisfy that, so that way you can work within the context of a proper population proportion. Enough of a sample size where that's satisfactory. Finally, the samples have to be independent of each other, so nobody can influence their answer. Okay, so it has to be truly random. All right, it can't be like one person influences another. All right, seems fair. All right, now the next part here is going to be, of course, the meat and potatoes of everything we're going to be doing here today. And that is, how do we perform a hypothesis test using the p-value method for a population proportion? Okay, so I've written out here some steps in order for us to go ahead and do uh, how to figure out the p-value method here. Now, this is going to be the primary method that we're going to be using here in this class to go ahead and do these type of hypothesis testings. All right, so let's go ahead and go through it one at a time, and then we'll see exactly how we can go ahead and do that in a real problem. All right, step number one is what we kind of focused on last time here. Like step one and step two is exactly what we talked about last time. So step one, determine the null and alternate hypotheses. So the null hypothesis here is that P is equal to the population proportion. So in the problem, it's going to give you some percentage or some proportion. That's going to be assumed to be the population proportion. So that's going to be our null hypothesis. Then, of course, there's going to be some claim made. And then, of course, that's going to be your alternate hypothesis here, which could be less than the population proportion, bigger than, or not equal to. Again, reflecting left, right, and two-tail, which is what we will also determine in step two, is the type of test, which will be left, right, and or a two-tailed test. All right. So before we move forward here, we're going to go ahead and take a look at an example. All right. And we're going to see exactly what we need to do in some of these problems. So, let's sure. All right. Okay, so we're going to go down to, here we are. Okay, let's go to number 20. Okay, so we'll go to number 20 here, and we'll go ahead and do this here together, and we'll see exactly how to work this out. All right, so this is eating together. All right, so in December 2001, 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. In a recent poll, 403 of 1,122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. As a proportion of families with children under the age of 18 who with children under the age of 18 who eat dinner together 7 nights a week decreased. Use the 0.05 significance level. All right, that's fine. Let's go ahead and bust out the paint tool for this. All right. So let's do the first two steps here. like we did last time with our previous examples. All right, just doing number 20 here. All right, step 1, we have to find the null and alternate hypotheses. All right. So first of all, let's talk about the null hypothesis. What is the null hypothesis here for this problem? What is the null hypothesis? What is the null hypothesis here for this problem based on what we see here for number 20? What's P going to equal to here? Okay. So is that a guess or your final answer there, Cool Dad? 0303. It's a very interesting way of. Chris is like 038. Okay, 0.38. Lock it in. Here you go. That's a I like that. Lock it in there. Finally. Wants a million yen. All right, so that is correct. So the answer here is definitely 0.38. All right, so that's going to be, as we've talked about before here when it comes to proportions, remember we always use the decimal equivalent to that of the percentage. So again, this is reflective of that 38%, but we always use the decimal equivalent. That part is true. All right, good stuff. So far, so bueno. All right. What is the alternate hypothesis here? What's the alternate hypothesis in this case? What is the alternate hypothesis in this instance? What's the claim made by the particular researcher in That's the next question here. Maybe not that. Let's go back here for just a second. Let's go back just for a second here, guys. Let's take a look here. Remember, the alternate hypothesis is going to be one of these three things that you see here for step 2. So 403 doesn't make any sense here. The alternate hypothesis has to be one of these three things that you see here on the screen. So what is that going to be? Let's go back here. It has to be less than, it has to be bigger than, or it has to be not equal to. Back to the wording of the question. Which one is that going to be here in this case? So all of you throw out some pretty good ideas, but we're not dealing with the numbers here in this instance. Let's do a small poll here. Okay. So you got three choices, okay? You got less than, you got bigger than, or you have not equal to. You guys can lock in the poll there up top, which one you think it is based on the wording of this problem. All right. Seems everybody's on the same page here. That's good. Good, good. I control all you guys, but I'm not going to. All right. Looks like everybody has taken a very large agreement here to be saying it is less than. Okay. And that is correct. Okay. So I want to at least point out one very important thing that's going to be going on here. Okay, we're going to have P here. Oops. I didn't put that in P here is going to be less than 0.38. All right, so I want to make a note in regards to that here. All right, so one thing to keep in mind about this here specifically, um, one thing to keep in mind about this specifically is that if you notice here, we have the same number for both the alternate for the null and alternate hypotheses. Okay, I'll get to your hydrate in just a second here, but um, so again, let's make a note regarding that. Note here is the same number for both H0 and H1. Okay, so again, that's pretty important there to note. Okay, that way you know that it's always going to be the same number. There are never going to be any different numbers going on in that in this case. Okay, so um, if you have 0.38 here, you should have 0.38 here, and it should be less than, bigger than, or not equal to. That's what it should always boil down to at the end of the day. All right, so should hopefully take away from some confusion in regards to how to set that problem up. Okay. Are there any questions about that before I move on? Any questions, guys? Any questions? Nope. All right. So, what type of tests do we have here? All right. Okay, good. Um, what type of tests do we have here? We have a left tail test, a right tail test, or a two tail test. It was a left tail test, a right tail test, or a two tail test based on what we have here in step number 1. Left tail. Okay, that's correct. So we are going to state here in this case, all right, very importantly, all right, yes, that's correct. Good. So what's very important here is to state the type of test. This is a left tail test. Okay, good. Because it is less than. All right. And they, someday I'll actually do this right. I can't. I can't. This is so hard to use for me sometimes. All right. Okay. Okay, good. Now, I'm going to show you why a little bit in just a second here about why this test is actually rather important. Once we get through a certain step here, we'll go ahead and see that here. All right, let's talk about a couple of other things here. We did discuss this last time here, but we'll discuss this here again. Step number 3. Step number 3 is to state the level of significance. Now, this is going to be given to you in the problem here. You don't need to find this out here. It's just going to be given to you here. So in this particular case, as I stated here last week, the most common levels of significance are 0.01, 0.05, or 0.10. Again, those are the most common ones. You may see different ones in different problems. It just depends. In our case here, we were given a level of significance at the very end of the problem using at 0.05, so that's what we're going to run with here in this instance. All right, so that's fine. Nothing too fancy going on there. It is what it is. All right. Now, let's move to the next step here, which we will get to right now. Now, next here is where we're going to start filling in the blanks here regarding some of the pieces of the puzzle in order to do this type of testing. All right, step 4 is to compute the test statistic. Now, this is definitely something here on the screen that is definitely worthy to write down. Okay, um, because certain problems here is going to ask you what the test statistic is going to be. So here is the notation here for the test statistic. So we have this notation here. Again, I don't really use the C0 here, but this is, again, if you do see this in the homework, when you do like a help me solve this or let's see an example, you do see this notation. At least you should know what that means at the end of the day. Um, Here, again, we have x over n, which is the number of yeses for x, the sample size, which is little letter n, p here for the population proportion here from the beginning of the problem, and of course the test statistic notation here. So x over n minus p divided by the square root of p times 1 minus p divided by n. Okay, so what we're going to do here specifically for this step is let's just go ahead and write down the test stat here again. I just write test stat as just the one word as opposed to the notation, but um, so I'll just write in the formula here, and then we'll start filling in some blanks here. At least we know what is going where in our particular problem. Okay. Okay. So I'm gonna step back here for just a moment. So let's take a good look here at our problem. All right. And let's see exactly what numbers that we do have here that we need to go ahead and put together. Okay. First things first here, we only have three numbers that we really need to find here in the test stat: x, n, and p. Now we already have p here, by the way. P here is that 0.38 that we found here from step number 1. That's our population proportion. Now all you need to tell me is what x and n are. So what is x equal to and what is n equal to? So can anybody tell me here, what is x equal to and what is n equal to? So x equals something and n equals something. What are those guys going to be according to number 20? And is a 1, 11, 22? Okay, I agree with that. That's right. All right, x is 403. Okay, very good. All right, that's good. Nice. All right, good. So this is where this is where we're actually going to implement those two numbers here, is doing it with the test stat here. Okay, so all of you are correct here. Very good in sussing that out. No problem there. All right, good stuff. Now, let's take a good look here and fill in the blanks. Let's fill in the blanks here because we also have P here. Again, just to reiterate here, um, P is going to be 0.38 as was stated here from up above. So, all right. So let's plug in and play these numbers here. All right. And so we're going to have 403 over 1122 minus 0.38. All right. And we're going to divide that by a little bit more space here. Have enough, but so I'm going to have the square root of 0.38 1 minus 0.38, and we'll divide that by 1122. Now, what I'm going to ask you to do next, though, is I'm going to ask you something more unusual after this part here, by the way. So what I'm going to actually ask you to do here as a request is don't put this in your calculator, okay? Do not try to solve this in your calculator. What we're going to do here specifically is we're going to find what the purpose of the question was to use this so-called p-value method. Now, there's going to be a p-value that we're going to find here in the next step. We're going to be able to find the p-value as well as the value of the test stat simultaneously, all right? So we'll be able to find that at the same time. So you don't have to enter this into the calculator, but you do have to sometimes in certain problems, you may need to enter this in order to just verify that this is indeed the test statistic in that case, all right? So, all right. So we're not going to solve this right away on the calculator. All right. We're going to try to find that simultaneously to go along with having this information, though, very important, by the way. But we're going to find that along with the p-value that we're going to intend to find here in this instance. All right. Now, let's take a good look here at the next step, and we'll see how to work with it. All right. Okay. Step number 5. Step number 5 is we're going to use the calculator. Going to use what's called the one prop z-test to determine the p-value. Okay, so we're going to use the calculator to find the p-value, and we'll be able to also find the value of the test statistic at the same time. All right, so let's go ahead right now. Okay, what I'm going to do is I'm going to bring up the calculator here. Okay, all right. All right, so good idea here is to go ahead and take out your calculator for this, as you will need the calculator for this to work appropriately. So again, please make sure you have your calculator out. I'm going to go through this very carefully, very slowly, so that way everybody is on board. Okay, let's take a good look here. All right, let's hit second and, not second, I should say. Let's hit the stat key, sorry. We're going to go ahead and hit the stat key here. We're going to go over to tests, all right, and we're going to scroll down to number 5. So number 5 here, that says one prop z-test, okay? So number 5 here, that says one prop z-test. Go ahead and hit enter. Now, we need to enter in some numbers here in this case. All right, so let's go down the line here. In this instance, we have P0. So P0 here happens to be 0.38. So 0.38 is the p-value that we had here from the beginning of the problem. Next, as you see here, we have X, which is 403, and N here, which is 1122. Now, the next part is probably why I put step 2 as a separate step. Now, this is because the calculator, the way to do this appropriately on the calculator is you have to actually tell the calculator what kind of test you are using it for. Okay, whether you have a, as you can see here, a two-tail test. So it goes like this. It goes two-tail, left tail, and right tail. Okay, so if you state the type of test, you'll know which one to go ahead and highlight, and you'll get the right numbers that you need for the type of test that you have for that particular problem. So since we have a left tail test here, we're going to go ahead and highlight the middle one here, and we're going to go ahead and hit enter on that. All right, so two tail, left tail, right tail. And we'll go ahead and go down to calculate here. All right, we'll hit enter. Okay, there we have it. All right, really quick, please type done in the chat if you have the numbers exactly as I have it on the screen. So please type done if you have the same exact numbers I have on the screen. The color doesn't do anything, Megan. It's kind of useless for what we want it at. It's just those extra things. Okay. Is the same as the z-test, or no? This is one cool data, one prop z-test. A z-score, it kind of is, yeah, like a kind of like a z-score, but it's more reflective of a test statistic. The z-score can be a reflective, yeah, it could be. You could say it's a z-score of some variety, yeah, but over a different type of distribution, possibly. Z-scores change because of distribution changes, cool dad. Um, uh, anybody having any trouble with their calculator? Any questions before I move forward? And we're going to go ahead and interpret these results here, so we'll see exactly how this works out. Okay. Nope. All right. So let's take a look at what we can see here. You good? All right. Good. All right. So let's take a good look at what we can see here. All right. Let's take a look at our results. First and foremost, we have our test stat here. So our test stat here, as we just talked about here, we did find that in this case. Again, we just had the calculator do it in our stead. So here, that's the z that you see here. Again, z-score does not equal the z-fighters. No, that's not how it works. That's not how any of it works. Goku would be ashamed. I mean, you know. Um, all right, so here we have negative 1.4368. Yes. Now look, Wade, there's one thing that you have to understand about my class. I always work off of super ultra instinct, okay? That's just how it rolls, okay? Somehow I've been able to teach nearly 20 years and it's always based off of super ultra instinct. All right? I'm as godly as Beerus. That's just how it has to be. All right? let's let's look at the let's look at the p-value here as well. Megan's like I'm a math teacher, okay? If I wasn't on the same level as the god of destruction, exactly how could I be upholding the standards of actually fulfilling the stereotype? I have to do it right. Come on, guys. Got to roll with me here. Procrastination when he hears anything weeb related. Absolutely true. Um, absolutely true. We're all weebs now. All right. All right. So what's the p-value here? Is 0.0754. Okay, so that's that next value that you see right below. Is this p that you see here is the p-value in question. This is the proportion that it found of doing 403 over 1122 and the sample size here as appropriated. All right, so now we have step number 5 here, which is the p-value that we wanted to find here in this process. We're almost there. All right, we do have one more step to do, so we're going to get to that here in just a second. But now we see exactly what numbers we want to actually look at once we use the calculator. All right. let's go ahead and go to step number 6 here. All right, so let's go to step 6 now that we're done using this. Step 6. Step 6 is we're going to make a conclusion, and it's a fairly simple conclusion here. As we know, there's only 2 possible answers that we could get during any hypothesis testing. Let's take a look at both of them here. So first of all we have to do is take a look at the p-value and compare it to the level of significance. So it says if the p-value here is less than the level of significance, then we reject the null hypothesis and accept the alternate hypothesis. Otherwise, the opposite is true. Accept the null and reject the alternate. Okay, so all we have to do is ask ourselves a simple question, and I tend to write out the same question here because I just want to know what 2 values I'm comparing here. I say is 0.0754, which is our p-value, less than the level of significance, which you stated here in step number 3, which is 0.05. So we're going to have, is this true? So basically a simple yes or no question. Is 0.0754 less than 0.05? Yes or no? No. Okay, definitely not, right? 0.07 is definitely not less than 0.05, right? So in this case, because the answer is no, right, we'll put down no here, no, then we're going to have to accept the null hypothesis and reject the alternate. Okay, so there we go. We have our final answer to this problem here. That's what we come up with. We can accept the null hypothesis and reject the alternate. So it's based on what we see here. It can't be concluded that it has decreased. So just doesn't fit within that scope. All right, that's the final answer. Any questions about that? No. Okay. All right. I want to be sure everybody's on the same page there. Like that. Oh no, I can't use it. So let's go. All right. Okay. So let's take a look at another example here. All right. So we'll do a couple examples here for sure. All right. Okay. So let's go ahead and take a look at 22. All right. Let's take a look at 22. And why don't you guys know in Spanish indeed? 22. So in 2000, 58% of females aged 15 and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether this percentage is different today by conducting a random sample of 500 females aged 15 and older and finds that 285 are living alone. Is there sufficient evidence at the 0.1 level of significance to conclude that the proportion has changed since 2000? All right, so this time here, I'm going to give you guys a good 2 to 3 minutes here. I want you to go ahead and try and work out the first few steps here as part of this process for number 22. And then we'll come back in about a couple minutes or so and put up the first kind of 3 steps here so that way. So, uh, then we'll go ahead and go through it together, okay? So go ahead and give it a try and see what you guys get. So let's take a little time to do. Put some music on while we. Probably can. Hey, what is that again? Oh, later. All right. Okay. Good stuff. All right. All right. So let's go over this problem here together here. Hopefully that'll give you enough time to go ahead and look this over here. Let's go through it one step at a time. Let's do it. All right. Be pretty simple, straightforward. All right. So let's look at the first part here. All right. So let's look at the null and alternate hypothesis. What is the null hypothesis? What's the null hypothesis? What you guys get? All right. Very good. That is correct. Okay, good. So P here is equal to 0.58. All right. excellent. So everybody got that perfectly fine. Recognize that we had 58% here was our baseline here. Excellent job, everybody. So far, so bueno. All right. Okay. Let's look at the alternate hypothesis. What is the alternate hypothesis here in this problem? The alternate hypothesis in this problem. I'd actually do that. That's something that you said not equal to, not equal to. Okay. All right. All right. Good. And why did you say not equal to? Okay. So I wanna this one I am gonna ask a reason. Why did you think it was not equal to? So I'm gonna agree with what you said there. But why do we say not equal to here? Okay. That's correct, Kristen. Right. It asked if it changed, but it's not greater or less than. That's right. So it didn't ask for an increase or a decrease. It only said if it changed. Absolutely. All right. Very good. I'm really glad you're picking up on that wording there. That's why I asked, because the wording there makes it a little tricky, but you saw right through that and you said it was not equal to. Good. Very good. All right. Excellent. Um, and Feiner has said it's a two-tail. Yes, that is correct. It is a two-tail test. All right, so it is a two-tail test. That is correct because it is not equal to. Very good. All right. That's correct, Demar. Absolutely right. Absolutely. I think, yeah. Okay. I probably will think about that for next time. All right. All right, let's go to step 3 here. Step 3 is just the level of significance. So the level of significance here is just going to be 0.1. Okay, so 0.1 or 0.10 if you want to put a 0 next to that. Fine. That's just given to you in the problem, so nothing really to talk about there. Okay, step 4 here was our test stat. We're just going to go ahead and fill in the blanks here. Again, we have our x, we have our n, and we have our p. We already know what our p is. Our p is going to be 0.58, so that part is a gimme. Okay, so no problem there. What's x and n going to be here in this case? What is x and what is n? $285 and $500. Okay, that's right. $285 and $500 here are perfect. X 285, N is 500. Absolutely spot on. Very good. Now remember, all you need to do is that once you have these three numbers here, you just gotta fill in the blanks, okay? But like I said, you don't need to plug this into the calculator. We'll find this out at the same time as we do our p-value. So let's go ahead and see what we get here. We're gonna have 285 over 500 minus 0.58. That's our p. Divided by the square root of 0.58. All right, and we'll divide that by, what is it, 500? Like a 6. There we go. Okay, perfect. All right. So again, you don't need to enter this into the calculator. We'll let the calculator function do it in our stead. So we don't have to like go way overboard for this. Shouldn't be too hard to do. Okay. Good stuff. All right. All right, next let's do our p-value test. Now that we have all the numbers, we can go ahead and do the p-value test here. Alrighty. Okay. So just put that off to the side here. Let's do our p-value test here. So once again, go for the homework, will we have to solve that equation or we still be figuring it out together? Are you talking for like the test stat? Yeah, so it may ask you for the test stat there. Um, so you may need to fill in the blanks for the equation, or they may just ask you, hey, what's the test stat? And then you go through the process there, making sure you have the numbers in the right places. So, um, yeah, that's basically, I'm just kind of covering my bases when it comes to that, Kristen, to be fair. Okay, cool. All right, so we're going to go down to one prop z test. All right, we're going to go to p0. So p0 here is going to be, in our case, 0.58. We have x here, which is 285, n here, which is 500. And in this case here, as you guys correctly stated, we have a two-tailed test. So let's highlight the two-tail case and hit enter and go down to calculate on there. All right, there we go. So in this instance here, all right, so we have a test stat here of negative 0.4531. So negative 0.4531 is our test stat. And we have a p-value here of, our p-value is going to be, oh, there it is, 0.6505, all right? All right, so we have that perfect. Now all we need to do is compare the p-value to our level of significance. So is 0.6505, is that less than 0.10? So is 0.6505 less than 0.10? Yes or no? No. Okay. Yeah, definitely not, right? That ain't happening. So what conclusion can we make here if the answer is no? If the answer here is no, what conclusion can we make in this instance? Let's take a look. I don't want guessing here. I want actual. Go ahead and take a look here. Which one of those conclusions would it be, Megan? Would it be what you said there, except the null? Okay. I want to take the guessing away. That's why I'm kind of I stress on this a lot. I want to take the guessing away, and we want to make actual concrete results here. That way, we don't feel like we're making the wrong moves every time. So yeah, accept the null here, and reject the alternate. Okay, good. Yeah. That's one thing about mathematics that I want to get rid of, in terms of like what I would like you guys free to do is to just, again, I want to remove like the guessing portion, because one of the problems with guessing, I guess, is the one thing in math that's actually true is that if you guess, you get very anxious. Okay, you get higher anxiety if you just guess on something, because then you just have this worrying doubt that what you guessed is just not going to, is not correct, and then it snowballs upon itself, because then you're guessing on things and it's not a consistent process to get every problem correct. So I want to remove as much of that guessing as possible, because at the end of the day, it will lower your anxiety to actually doing mathematics in general. So except yes, that's correct, Demar. Very good. That is correct, Demar. Yeah, yeah, and I totally understand that. Anxiety comes from a lot of different places, but that's one of the first places people get their anxiety from, is that when they don't know what they're doing and you guess, you just basically snowball that anxiety upon yourself, because you have two factors. One, you just feel lost, and two, you're just kind of guessing on things and you're just like hoping and praying that it's true. It's like guessing on multiple choice. You're just like, yeah, I just hope and pray, and it's just like that doesn't net you consistent results, unfortunately. So, I want to, at least that's why I show things step by step, because I want to take away that portion and be like, hey, this is what we do. We do it a good once through carefully, and that takes away that moment of anxiety that you may have doing problems. So once you get the practice down, then it becomes a lot more relaxed, because then you have more confidence about knowing what you're doing part of the process. So I used to have some anxiety when I did tests, and you guys have probably been through the same thing. Sometimes you blank out when you first look at a test or whatnot. Sometimes you just need to take a step back or sit down for a minute or two and just kind of look through the problems, just kind of see what you can do and see what you can't do, and just hopefully you know start to build that, build a little by little from what you remember, and then start putting it together. Yeah, and that's fine. It's fine if you still do. That's not a pro. It's a portion of improvement. It's a portion of improvement that you need to make. And again, doing tests is not just applicable in academia. Okay, academia is one place, for testing. But remember, that anxiety actually transfers over into other real life situations that may not be academic related. Okay, so um, that would make me sad. That would make me sad. So, in real life situations, you get, when you're put into a situation you have no idea, when you have no idea, decision making is very important. So, you know, it's one of those things that you have to learn, is like you got to take a step back and say, okay, let me think through this scenario here. What can I do in this scenario here? Sometimes it's a momentary thing. Sometimes you have some time to think through it. Sometimes you have a few, a minute or two, or maybe a few seconds to think through it. But you have to, if you can remain calm as best as possible, and it works wonders once you can. So, but it's not an overnight process, not by any means. Same thing I do with when I'm driving. I try and remain as calm as possible, despite everybody else on the road being absolute morons driving around. So, you know, because people are bad drivers. That's just what I assume. Everybody sucks at driving. It works out very well. By the way, that that doesn't mean I'm good at driving either. So I'll be honest with you, Megan. It works. It works. Okay. It absolutely works. All right. 100%. All right. It works, because then you could be a good defensive driver. If everybody sucks at driving, look, I've been in like crazy situations on the highway and the roads. I'm sure all of you have, driving around town. You've been through, seen some crazy things. And you got to know how to kind of deal with it as best as possible, and make some split second decisions. So You know, it isn't easy, but you know, it does help significantly. All right. Are there any questions about hypothesis testing for population proportions? Any questions? All right. No. All right. Yeah. See something here. Second. I don't think that's. Yeah, I wanna. Okay. I did the little different. I'm not sure if that's gonna work. I should have done that earlier. Oh well. Ah, whatever. All right. That's fine. Hopefully, I can get Super Mario Maker 2 to be working on this platform for next time. If I can see if I can get that going to some degree. Not sure if I can. I should be able to. Um, yeah, I do have a capture card here, so if I add a source, they add a new. All right, let's give this a try. All right, so I'm just gonna experiment a little bit on stream here, see if this works or not. So let us see. If I turn this on, does that work? Yes or no? Oh, it does. Look at that. It does work. Holy smokes. The answer to there's questions I have to ask. Tell me, oh, that's a well, that's a problem. If I have no juice in my controller, that would be a problem. That would be a slight issue. Like, controller, why don't you work for me? Like, bro. Okay. Looks like I gotta update the software there. I haven't updated this to see. Let me see that switch code. uh, although I'm not getting any sound out of it, so I guess I'll have to figure that out later. Uh, I wonder if that would work. Wonder if that would work. I don't know. Can you guys hear the sound or not? I'm guessing there's no sound, right? No, I didn't think that there was any sound. I have an Elgato. I have a S60 Plus. Yeah, I'll have to figure out sound at another time. I don't know if that what I have to do for that because I'm just kind of setting this up all guerrilla style. Yeah, I've gotten this to work before. Like I've legitimately gotten this to work before. I just don't know how I can do that here off. Actually, let me see if this works. Let me check if this. Okay. That is that working? Think they're two separate apps? I don't know what notifications I have. Okay. This is from a long time ago. You heard it for a second? Oh yeah, that's probably maybe it's coming through my microphone, which is entirely plausible. Yeah, I'll just have to figure it out at some point. I don't even know anymore. See if that does anything. No. Or actually, go to my maker stats. Sure. I can do that. I haven't played very much of Maker for quite a while, so I've played a few courses though. Like I said, I'm not good with this game, but still, I give it a shot. let's find a course, right? Let's just find a random course and see how good I remember how to play this game. So see how well it runs too. One other thing I gotta actually recognize, I gotta remember how well this runs on my capture card. There we go. Oh, you know I'm gonna fall for that. Baby. Super slow, guys. Right there. You want that ID? How do you get down there? Oh, I know how you get down there. What am I? That's how you get down there. There we go. Got it. Nice. Nice simple level. Not too bad. Yeah, you could throw. Yeah. Here. Where's my maker ID thing? Where's that? Sure. I don't think that's the right. I mean, finding me on here is pretty easy. Was it there? Oh, I'm sorry. Where was it? Did I just miss it altogether? Let me check. Oh, there it is. There's my ID. You're right. It was there. Yeah, yeah, yeah. There, you can add me if you want, Cool Dad. It's perfectly fine. You go ahead and add me. That's perfectly fine. I'll somehow figure out audio once I get things going with this thing. I've had issue. Yeah. So everybody can create their own me on the Switch. See if that works. Oh, This? No. The question is, why is the Elgato only go through... No, that's not right. You're here to steal all my world records. That's fair. Let's play troll levels for no reason. And we'll do a marble level, guys. I have no words about what the heck this is. Look at this. What are these faces? Oh my god, what are these faces? Holy smokes. What is this? This is Super Mario Maker, yes. Yes, indeed. This is Luigi Gets Revenge on Mario. And you can see see those faces. Oh my gosh, it's so funny. Hilarious. This is so dumb. Let's BO. Oh, bonk. It's just a BO. Holy smokes. So silly. I have no words for that. I have no words whatsoever. So silly. So absolutely silly. The music levels in this game are really good too. If I had sound going, then I would play those, but that wouldn't make any sense. Unrivaled storytelling. That's true. Let me tell you, I can't deny how how terrible it was. It was so bad. All right, let me oh no, I clicking the wrong button. Clicking the wrong button, guys. That reminds me, I gotta continue with Atelier. That reminds me, I gotta do that. That does help with that if I change it over. Doesn't help with the audio. I will have to cut it out. Time goes. Gaming stream. I can game. I mean, gaming is not difficult. What I may end up doing a few tweaks here for next stream. A couple things I may end up doing is um actually I need some feedback from you guys here who are on stream right now. I know you guys. I try and stream at 1080p for all my streams. Do you guys want me to keep it at 1080p or should I lower it to 720 at 60 frames? I'm currently at 1080p at 50 frames, but would it be easier for your computers if I lowered it to 720 for 60 frames? Would that be easier for you at 720p 60 FPS? Because if you want me to do that, I can do that for the next stream moving forward. If you feel like okay. Okay, you have a gaming laptop. Okay. Yeah, I just want people's opinions. Like if it kind of hangs up a bit or whatever, then kind of does what it does, and I'm like, all right, well, whatever. Yours is good? Okay. It's fine then. Alright. Can we just... You can change the quality to a lower quality, that's true. Yes. It's just that my auto quality is always at 1080p 50 frames per second, so I don't know if that messes with people's computers or not, which is why I just kind of ask. Anyway, just to be on the safe side. All right. Well, if that's the case, I can. I've been fine for you. Okay, that's fine then. No problem. If that's the case, that's not a problem then. All right. Wonderful. All right, ladies and gentlemen, thank you very much for coming on out here to the stream once again. Thank you very, very much. Hopefully I'll make some tweaks here before here in Wednesday. In the meantime, though, I do want to thank you all for coming out here to the stream here. And if you are here for the second class at 12:30, of course I'll be sticking around, sticking on. So in the meantime, though, as I want to say here, probably haven't said it in a while, but still, everybody, thank you very much. Love you all. For those of you who are leaving here, stay safe, stay healthy, and most importantly, stay sane. All right, very important here to stay sane, 100%. All right. Thank you guys so very much here once again. We're going to be going over section 10.3 here next time, which is the end of chapter 10. Okay, so the end of chapter 10 here will be section 10.3, and we'll discuss about that here going forward for next time. All right, have yourself a wonderful day. I'll be around here for the next 10 minutes here before class. But in the meantime, though, everybody enjoy your lunch, enjoy your day, and have a great one. All right, we'll see you later. Okay, hello, hello, hello. Hello, 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 I'm back. Hopefully everybody's doing good today. How's everybody doing today? Hopefully everybody get a few more people to trickle in here for the second half. Alrighty. I'm gonna get started here shortly. So. How are people?
Because you have so little faith. Truly I tell you, if you have faith as small as a mustard seed, you can say to this mountain, move from here to there, and it will move. Nothing will be impossible for you.
Alright, got about a minute to go. We'll go ahead and get started here. Once we hopefully have some people. Oh. Hey, there's Planet! Oh, there we go. We have Planet. How you doing, Planet? We doing good today, Planet? I hope so. Hopefully you're ready for another rip-roaring day of amazing times with me. Yeah. Forgot to do this. How was your weekend, Planet? Hopefully your weekend was good. Indeed. You have been, actually, yeah. Yeah, so you've been on time for once. That's true. That's true. That's true. That's true. Spend your time in the couch. In the couch. Not on the couch, but in the couch. So there's like a little cubby hole you spend your time inside of, like a little mini fort. Is that what you mean? Like the real comfort of the couch is the fluff in between the cushions as opposed to on top of the cushions. I see how it is. I was a couch sandwich, apparently. You got a best kind of sandwich, a couch sandwich. Oh my goodness. How did you know? uh, how do you get to be lazier? You just sink into the couch and never to return. Hey, JD! How are you doing today? Did you have a good weekend? You good? Good. Hopefully you had a nice relaxing weekend. You know, sitting and chilling, having a good time. Ready for class. Never a bad thing. When in need of blankets, you improvise, you must. You're shipping the bees today? Oh, okay. How many orders do you have now to make? Like I know you got a few orders. I was reading the Discord chats there, and I saw that you got a few orders there. So you know. Look at that, man. Don't you love when things come together like this? I can't really argue with any of this. Man, so good. You got requests but no orders. Okay. But you gotta put yourself out there, JD. You gotta make sure that you have if you have a website or something. Maybe not a website. Maybe you set it up through your Instagram or something, like saying, "Hey, contact me here if you want an order." You know, they send you money through Venmo or something, and then there you go. Yeah, just make sure you have the proper infrastructure so you can handle that. You know, realistic turnaround times, and of course a way that they can, deliver money to you, and then you can give them their goods. So, never a bad thing at the end of the day. Alrighty. Oh, look at that. Easy. All right. Well, I'll let you guys figure that part out for yourself. That is not a problem. There you go. Yeah, just send it over Discord. You guys will be fine. All right. Alrighty. Well, hopefully we are ready to go here, because, yeah, we are definitely ready to go here. All right. All right, ladies and gentlemen, let's go ahead and, all right, let's go ahead and we're going to go ahead and get started here. Let's do some intros. Let's get it going. All right, let's do this. Okay, let's get started today. Welcome back to Monday. Hopefully a nice weekend. All right, so for today we're going to get into the next part of Chapter 10, which is Section 10.2. Last time we went ahead and did Section 10.1, which set the groundwork for what we're going to be doing here in the rest of Chapter 10. It's 10.2 and 10.3 here, but today we're going to be doing hypothesis testing here. In a particular scenario here, in this case, using population proportions. So we're going to see a lot about what we did here last time. and kind of setting up that groundwork and being able to apply that to an actual real world type of problem here, real world type of word problem here in this instance, in order to see if the test would pan out or not based on the scenario given. All right, so that is essentially what we are going to be doing here today. All right, so we are going to plot ahead here with a couple of examples here for today. We're going to go through it carefully, step by step, okay, so we can see exactly how things will work out. So let's go ahead and go to the big board here. All right, so let's go to the big board here. We're going to probably just delete that. Yeah. Anyway, I'll figure that out later. All right. In any case, all right. So today what we're gonna do here specifically is like I said, we're gonna figure out exactly how to do hypothesis testings for population proportions. Now, this is the handout here from last time. This may be question 1 here from section 10.2, or it could be section 10.1. In section 10.1, I just want to give a friendly reminder about what we talked about here last time. Last time we talked about significance levels. Okay, again, significance levels is what we're going to be using to compare, to do proper comparisons with. We also talked about, again, there's only 2 conclusions. There's only going to be 2 final answers that we're going to talk about here. So 2 conclusions here: either we accept the null hypothesis and reject the alternate, or we reject the null hypothesis and accept the alternate, whichever way we want that to happen here. And we also, last time here, hello? Last time here, we also talked about left tail, right tail, and two tail tests. Okay, again, setting up the null and alternate hypotheses in this manner. All right, so we did talk about that here last time. So we have a pretty good idea about how that will go. Now, today, let's take a look at number 8, which is going to be maybe question 1 here on your handout for 10.2. In any case, let's go ahead and take a gander here. Before we actually read that off here really quick, are there any questions from last time that you guys have? Any questions you guys have from last time? So just want to be sure. No? Okay. I just want to be sure that everybody is on the same page, but just anything that clean up from last time here. Okay. All right, good stuff. Okay, so let's go ahead and take a look here at number 8. So it says, what assumptions must we make to do a hypothesis test for a population proportion? All right, so let's take a look at all 3 of these assumptions that we have to make in order to do this particular hypothesis testing. So letter A, we have to have a simple random sample or data from a randomized experiment. So it has to be random, it has to be simple and random. All right. So again, it could be again anyone. It can be equally chosen to be as part of our sample. All right. Letter B is something that we actually used in a previous chapter. It says NP times 1 minus P has to be bigger than or equal to 10. This just ensures that we have a large enough sample size to give an actual proper context and actual meaning behind what we're going to be doing. So again, we definitely want this to happen here. NP times 1 minus P has to be bigger than or equal to 10, so we have a large enough sample size. Remember, 10 people is not going to be enough. We're going to definitely need more there depending on the proportion at hand. And then finally, the sample values are independent of each other, meaning one person can't influence another person. Okay, so there has to be truly randomized in nature without as much bias as possible. So taking away the bias there, it has to be truly independent in that regard. Okay, so let's talk about what we're going to be doing here today, at least the first 2 steps, which is basically what we did here last time. So let's take a look at number 9 here, which is the meat and potatoes of everything we're doing here today. So how do we perform a hypothesis test using the p-value method for a population proportion? So step number 1 here is we're going to determine the null and alternate hypotheses. Now we did talk about this last week. So what's the null hypothesis here? So the null hypothesis here is going to be equivalent to P being equal to the population proportion. Now, The population proportion here will be given in the problem. So just look for a percentage or a decimal. That's going to be reflective of the population proportion here given in these problems that you can go ahead and work with. Okay. Now the alternate hypothesis, on the other hand, is where P is going to be either less than, bigger than, or not equal to that particular population proportion that we found from the null hypothesis, our base case there. And again, as if you recall, this all leads to the type of test here. So again, less than is left tail, bigger than is right tail, and not equal to is a two-tail test, which we will state here in step 2, which is to determine the type of test left, right, or two-tail. We will have an importance for this here once we take a look at the rest of the steps here. Okay, so a lot to be said here, certainly, but let's go ahead and use it with an example. We'll do it simultaneously with an example here, and we'll take a look at how that works. All right. Okay, so the question that we're going to look at here in this instance is going to be number 20. So let's take a look at number 20 here from the textbook. All right, and we're going to see exactly how we can go ahead and start putting it together to get the conclusion that we want. All right, so number 20 says, in December 2001, 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. In a recent poll, 403 of 1,122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. Has the proportion of families with the children under the age of 18 who ate dinner together 7 nights a week decreased? Use the 0.05 level of significance. All right, so sir, significance level. Okay, so let's go through this carefully here, one step at a time. All right, this on the left here. Okay, let's go to step 1 here, and let's take a look at what we have. All right. Let's look at the null hypothesis. What is the null hypothesis here in this problem? So what is the null hypothesis here? What is our population proportion here according to the question at hand? Can anybody tell me here what the population proportion here would be for this problem? Would P be equal to? What is H0? What is the null hypothesis here in this case? Can anybody tell me? What would be the null hypothesis here? So JD says 0.38. Okay. Say 0.38. All right. That's correct. All right. Very good. So 0.38 is correct, right? We say 38% of adults reported that they eat 7 nights a week together. All right. So remember that, again, we're changing all the percentages over to decimal. That's always pretty much for the most part true. So in this case, that is definitely true here. So 38%. Very good. So that is going to be our null hypothesis. That's our base case. Let's take a look at the other part here. What is the alternate hypothesis here? So now let's answer this, ladies and gentlemen, here. What is the alternate hypothesis here? What is this going to be here in this instance? What is the alternate hypothesis? Is the alternate hypothesis according to the wording of this problem here? Hmm. What do we think the null hypothesis? 0.05? Not quite. That's 0.05 is the level of significance, but it's not the alternate hypothesis. Remember, the alternate hypothesis is a claim here. 0.403. No, unfortunately, 403 or 0.403, not quite here in this case either. Um, let's go back here. Both are very good guesses here, but this is the important part about what we did here last time. Let's go ahead and refresh ourselves here for just a second. Take a look at step 2 here, or step 1 here again. Remember that the alternate hypothesis here has to be you either have P is less than, P is bigger than, or P is not equal to the population proportion here from step number 1. Okay, so either you're going to have one of three things, either less than, bigger than, or not equal to. So which one do you think it is? Is it less than, bigger than, or not equal to? Which one of those three is it going to be? So is it less than, is it bigger than, or is it not equal to? I'm going to go back here for just a second so you can see the wording here. Which one do you think it's going to be based on the wording of this problem? This is the big, this is one of the big cruxes of this problem here. Okay, why do you feel it's less than, Planet? Tell me a reason. I don't want guesses. I want to have a good reason behind that guess. So just random guess is not going to cut the mustard for this one. Why would it be less than here? What's the dead giveaway here that it would be less than? No, not under the age of 18. That is not the wording that you need to be looking at. Remember, it uses the word decreased. Okay, that is correct. Okay, very good. Now you need to be very careful about the wording you need to look at. Okay, and I stressed this last time. I'm going to stress this again. All right, so, and this is why I've asked this question here. It doesn't matter about the under the age of 18 because that's just the premise. The claim that this person is making is, has it decreased? Okay, so that's the important word there. Has it decreased? Is it less than the 38% or 0.38 that it was at before? That's the important part to this particular problem. So P here is going to be less than 0.38. Now, one other thing to keep in mind here, by the way, and I'll make this note here for this particular problem, is, let's go ahead and put this here. So one big note here that I do want to make is that you will have the same number for both H0 and H1. Okay, so both the null and alternate hypothesis will have the same exact number. So if 0.38 is up here, you're going to have 0.38 down here for your alternate hypothesis as well. All right, so these should not differ by any number. They should always be the same. All right, so make that note there, put that in your notes there so that way you remember, hey, I'm not going to change this number around once I have the population proportion. If this is 0.38, this is also 0.38 down here. All you need to determine is whether that's less than, bigger than, or not equal to, depending on the wording of the problem. So that makes that portion there relatively easy to work with. Okay. Are there any questions about that before we move forward? Hey, Desmond, how you doing, my friend? Who indeed. Awesome. Wonderful, Desmond. Sounds like you had a wonderful weekend. Nice. Nope. All right. All right. Let's go to step number 2 here. Having some keyboard problems right now? Oh, okay. Well, I like the words nice and awesome. That does sound good. um, all right, what about step 2 here? Step 2 is talking about the type of test, okay? So what type of test do we have here for this problem? Do we have a left tail test, a right tail test, or a two tail test? Try typing an answer. It says unrecognized. Ooh. Um. Oh, that's a problem. If you put a slash, then if you put a slash, then it's thinking that it might do a command. So don't put a slash in front of your response there. Left. Okay, very good. So that is correct here. So in this instance, we have a left tail test. All right. Okay. So having this as a left tail test, we're going to state this as a left tail test here. This is going to be incredibly important later on here as part of this process, but I do state this as a separate step, so that way, again, it'll give you a good friendly reminder by the end of the problem. All right, let's take a good look here at step number 3. Okay, and then we'll write step number 3 down. Step number 3 is pretty simple. That is state the level of significance. Now, one thing that I mentioned here before is that the level of significance here is given to you in every problem. Okay, so you don't need to go ahead and solve for this in any form or fashion. This is just basically what you're comparing stuff with. Now, in our problem here, our level of significance is 0.05, as it says here at the very end. So use the alpha is equal to 0.05 significance level. So we're just going to state that here in this problem. All right, and then we'll go ahead and use it here later on. All right, so that's what we have going on here next. All righty. Now, let's focus on the next part of the problem here, step number 4. All right, so step number 4 is where things start to ramp up a little bit. Is we want to compute what's called the test statistic, okay? So what we're going to do next is compute what's called the test statistic, all right? So let's talk about the test statistic here. We'll talk about step 5 here as well. All right, so first of all, the test statistic here is the formula here for the test stat. So this is definitely one thing that you probably should write down here because possibly some problems could ask you to go ahead and fill in the blanks about how to find the test stat. All right, so again, you have the formula here in front of you. We're going to be using this test. We're going to be finding this test stat here with this formula. Now, I put it in notational terms, so as you can see here, X here is the number of yeses, N is the sample size, P is the population proportion here that we have here from step number 1, and of course Z0 here is this test stat itself. So again, it's not too big of a deal. And I put the notation of Z0 here only because of the fact that if you do see this for like a help me solve this or view an example sort of thing in my math lab, at least you'll know what that notation means in the context of this problem. All right. In any case, for what I like to do is I like to just put test stat down. I'll just put the words test stat here. It's because it's a heck of a lot easier. Now, for the purposes of this problem here, we'll go ahead and rewrite this write this formula down here. So x over n minus p divided by the square root of p times 1 minus p, all divided by n. All right. So what we need to do here in this part of the problem is first figure out what our x and n and our p are. Now p is pretty simple because that's already given to us here. Okay, but let's take a look at the rest of them here. So we need x, we need n, And we already have P here. P here are given to us as 0.38 from the very first step. So taking a look at this problem here for number 20, what is x going to equal to, and what is n going to equal to? What is x equal to, and what is n equal to? What does x equal to, and what does n equal to? So take a look at 20 there. What does x equal to? What does n equal to? Anybody can tell me? I hope so. So n is 1122. Okay, that's correct. All right, good. 1122. And x here is, JD says 403. That's right. Okay, so the sample size here is 1122. 100% right, Desmond. And x here, the number of people who said yes to our question here, was 403. All right, that seems fair. So all we're going to do here is we're going to just plop in the numbers into the formula here, and we'll see what to do next. All right, let's do it. Okay, so let's write this down here. So we have 403 over 1122 minus 0.38. We'll divide that by the square root of 0.38 times 1 minus 0.38 divided by 1122. Okay, good stuff. All right. Now, okay. So, I'm going to make a very pretty strange request here, by the way, next. Okay, so we've entered in all the numbers here into the test stat formula. Great. But what I am going to ask you to do next here, I know, wow. What I am going to ask you to do next here is to not enter this into the calculator. Okay, do not enter this into the calculator. As you can see, that is exactly right, JD. It does look rather complicated, but we're going to let the calculator solve this in our stead when we go ahead and do the next step here, which is going ahead and finding the p-value. So although we have this all put in and it looks really messy, don't worry, solving for this is actually really simple because we're not actually going to enter this into the calculator at all. We're going to have the calculator pretty much do all the work for us all in one go. And at the same time, going to find the other most important piece of critical information. So we'll kill two birds with one stone here essentially when we do the next step. All right, so let's look at step number 5 then, which is the next step, and we'll come back to step 4 here, by the way. We'll find out what this is equal to momentarily, all right, as a test stat. Oh, sorry about that. Okay, so the next part here is you're going to need your calculator for this next part for sure, okay? And if you've listed everything down already, you should be good to go for what we're going to be putting into the calculator, all right? So the next part here is we're going to, step 5 here, use the calculator, one prop z-test, that's going to be the function on the calculator, to determine the p-value, okay? So we need to find the quote-unquote p-value here to make our proper comparison to have our test to make a conclusion based off our test. Now, in order for us to do that here, let's take out our calculator here. All right, we're just going to go slow here, one step at a time. We're going to see exactly how we could find this p-value and our test stat at the same time, simultaneously. All right, so let's hit the stat key here. We'll hit the stat key and we'll go over to tests. Hit the stat key and go over to tests. Now, scroll down to number 5. Number 5 says one prop z-test. Okay, so number 5 says one prop z-test. Okay, now, as we can see here, you should get to this little submenu that you see here on the screen. Now, the very first value here is going to represent our population proportion. So that's our p-value that we want to compare with. That's going to be 0.38. Next is our x and n. So our x here was 403, and our n here is 1122. All right, two pretty easy values now that we have it listed down. Now, the next part here is why we state the type of test, is that you have to tell the calculator the type of test that you want to make. All right, so we have a left tail test. That's what we stated here in step 2. We have a left tail test. Each one of these options represents a type of test in the calculator. So the first one here represents a two-tail test, then a left tail test. And so we have a two-tail test, then a left tail test, and then a right tail test. And that's two-tail, left tail, right tail. Okay, in that order. All right, so as we can see here, we have a left tail test that we want to use. So we're going to highlight that middle box right there, and we're going to go ahead and hit enter. Okay, and that will represent our left tail test. And we'll go down to calculate, and we'll go ahead and hit enter here as well. Okay, and these are the values that we get here. All right, so before we move forward here, I want to be sure, please type done in the chat if you got the same exact numbers that you see on screen. Please type done in the chat if you get the same exact numbers that you see here on screen. Okay. Just want to be sure that nobody is having issues with the calculator and whatnot. Be sure that we're all on the same page here. Hopefully everybody's all right. All right. Good stuff. All right. Anybody have any questions? Any complications? Take like 10 seconds here. We'll see if anybody's having complications here. Okay. That's perfectly fine. All right. And all right. If you have questions, just feel free to stop me if you're not sure. All right. Okay, now let's take a good look here at the results that we see here on the calculator and where they need to go. All right, first things first here. We see the Z. All right, this is a Z-score, aka this is our test stat that we were going to go ahead and find. So as you see there, the very first value that we see here is our test stat, which is negative 1.4368. All right, so again, as I mentioned here, you didn't need to go ahead and find out what the test stat is by entering all that stuff, complicated stuff in the calculator. It found it for you. How convenient. The next number that you see here is the p-value in question. So the p-value in question here is going to be 0.0754. All right, so that's the p-value in question. This p-hat here represents the 403 out of 1122 as a decimal, and of course the sample size right after that. All right, seems fair. Okay, so that's how we can do, again, finding the conclusion of step 4 and step 5, which is our p-value. Okay. Now, of course, the next part here, which is the last part, talks about what we need to do here in order to start making our conclusion here and getting our final result. So let's talk about step 6, making a conclusion. So, how does it work in terms of making our conclusion here? Well, the way it works is we need to compare our p-value to our level of significance. That guy that we talked about here back in step number 3. So we did state it here in step 3. Let's go back over here for a second. So here's step 3. We haven't used it yet, but this is where we go ahead and use our level of significance and our p-value here together. The way it works like this. It says if the p-value is less than the level of significance, then we reject the null hypothesis and accept the alternate. Otherwise, if it is not, then we accept the null hypothesis and reject the alternate. Okay, so what I like to do here for this particular part, in order to have it make sense, is I just ask a simple question. All right, I say, is the p-value, which is 0.0754, is it less than our level of significance, which is 0.05? So let's just boil it down to a simple yes or no question. Is 0.0754 less than 0.05? Yes or no? So can you guys answer that? Is 0.0754 less than 0.05? Yes or no? Okay. So the answer here is definitely no, right? So I'm just going to write in the word no. Okay, very good. Oh, good, Tristan. You're back. All right, cool. All right, uh, so the answer is no here. So since the answer is no here, what we're going to do here is we're going to go ahead and accept the null hypothesis and reject the alternate. Okay, and that's how we go ahead and figure out our final conclusion, our final answer here to this problem, is we accept the null hypothesis and reject the alternate hypothesis since 0.0754 was not less than 0.05. Okay. Any questions about that example? I did that one. We're gonna do that one though. Any questions about this example here? Oh, I'm doing great, Tristan. I'm doing very good, Tristan. It's okay if you missed the early class. That's not a problem. You're always welcome to the late class. That's not a problem, Tristan. You can come to either class, and that's perfectly fine. So you're always welcome. It doesn't mean you're excluded from one. Like, no. As I teach these back to back, you're always welcome to come to the late class just in case. So always give options because life happens and stuff happens. So yeah, it's all good. All right. Good beans. Okay. Good. All right. So there are no questions here. Let's go ahead and move on to the next one. Now, in this case here, we are going to. I'm going to have you give it a try here for a few minutes. We'll go take 2 or 3 minutes here. So let's go ahead and take a look at 22. So take a look at 22 here. All right, I would like you to try that problem. So let's give 2 or 3 minutes. Let's give 3 minutes here. And let's have you guys, again, set up the problem here. Again, step 1, step 2, step 3, and all that jazz. And see how we can set this up, and we'll work with this together here. But again, set up the problem here and see how far you can get, again, to do this problem out here correctly, okay? So I'll go ahead and read this off here, and then you guys can give it a go. So in 2000, 58% of females aged 15 and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether this percentage is different today by conducting a random sample of 500 females aged 15 and older and finds that 285 are living alone. Is there sufficient evidence at the point 1 level of significance to conclude the proportion has changed since 2000? Okay, so let's take a good few minutes here. And let's see if you guys can make sure you set it up here. I put the first 3 steps up here on the left. So that should give you a little bit of inspiration. Let's give it a go. Put a little bit of music on. Simple music here for 2-3 minutes. So another couple minutes or so. Alrighty. Give this a go here. Alright, let's give it a go here. Alright. So. Okay. Okay. Let's look at the problem here. All right. Number 22. And we're just gonna go through and see what you guys have, and then I'll follow what you guys have here. We'll see what we get. All right. What is the null hypothesis here according to number 22? What would our null hypothesis here be? What is the null hypothesis according to number 22? All right. 0.58, that is correct. All right. Very good. Oh, be careful there, Tristan. Okay. Yeah, okay, good. So 0.58. Very nice. All right, good. Whew. A little scared there for a second, but okay. You are correct. All right. 0.58, absolutely spot on here. That is definitely what our null hypothesis is going to be. All right. Now, let's take a look at our alternate hypothesis. What is our alternate hypothesis according to the problem? The null hypothesis according to the problem. What do we have here? What I do know is it's just going to be P and something is 0.58. Planet says P is not equal to 0.58. Okay, very good. That is correct. What was the tip? What was the tip off here for you to say, hey, this isn't equal to 0.58? Why is it why is it why is it not equal to? So I'm just asking here, what's the reason why it's not equal to? What was your tip off there? What wording told you that it was not equal to? I agree with the answer, mind you, by the way. Not equal to is correct. I just want to know why. Where in the problem does it kind of imply that it's not equal to? Percentage is different today. Uh, okay. Okay. Yep. All right. Yeah, that's kind of in the middle of the problem. That's true. Yeah, so a sociology test whether this percentage is different today. It says it said if it had changed, but it didn't say direction. That's okay, good. Both are perfectly valid reasons. Absolutely true. Right? So it says, does it conclude that the proportion has changed? So it doesn't say it's bigger than or it doesn't say it's less than. It just said change, right? Or it's different. So again, that represents not equal to there. So again, I'm definitely true there. So again, remember to be very extra sure there about watching out for your wording there. All right, 100%. There you go. Nice work. All right. What type of test do we have here? Let's go to step 2. What type of test do we have here? Do we have a left tail, right tail, or two-tail test? What kind of test do we have here? Two-tail. Okay, good. So let's state that next. We're going to have a two-tail test here for our guy. All right. All right. Okay, so we have that. That wasn't too bad. Again, not equals represents a two-tail test. Now, we have the level of significance here, which is 0.10. Okay, so 0.10 here is the level of significance. All right, that's just given to us at the end of the problem there. No problem. Simple as pie. All right, let's move to step 4 here. Let's see what we're working with here for step 4. Now, of course, we have some values that we need here for step 4. We need an x, we need an n, and we also have p here. So let's restate p here, which is 0.58. But according to the problem here, what is x and what is n? So what is x equal to and what is n equal to? What do we have here for x and n here in this problem? So x equals something, and x equals what, and n equals what? Okay, very good. All right, x equals 285, right? So that's 285 females who said yes, okay, live alone, out of the 500 that were polled. Okay, excellent. All right. All right, so all we're going to do now is just plop these numbers into the formula. So we're going to have 285 over 500 minus 0.58 divided by the square root of 0.58 times 1 minus 0.58. And we'll divide that all by 500. Okay. So this is going to be our, again, our test stat here in this instance. Okay, so we'll figure that out here in just a moment. Okay, let me get rid of this stuff here. Okay, so the next part here that we're going to look at is, let's look at the p-value here. Okay, let's go to our calculator here. Let's use the numbers that we have here, and let's see exactly what we get. Okay. Okay, so let's hit the stat key here once again. Hit the stat key. Go over to tests. We'll go down to number 5, which says one prop z test. We'll go ahead and hit P0 here. Again, that's going to be our p-value here, which is 0.58. Our x here is 285. We have 500 as our n. And then finally, we have the type of test that we're working with, as you all have correctly stated here, to be a two-tailed test. So in this case, we're going to have that first one highlighted there with being at not equals, and hit enter on that. And then go to calculate. So let's take a look at our test stat here, and hopefully you got the same results I did. The test stat here is negative 0.4531, and our p-value here is 0.6505. Okay. 0.6505 is what we get here for our p-value. Now, okay, let's look at our last step here. All right. So our last step here is going to be, again, comparing the two. Okay, actually I should put this on the right. Okay, so let's see here. Is our p-value 0.6505? Is that less than the level of significance we have here at 0.10? So let's answer this question here. Is 0.6505 less than 0.10? Aw, made you mad. Sub for the 7 months. Bro, thank you for the prime sub, buddy. I don't know why you continue to sub with me for 7 months, but I appreciate you very much, dude. I appreciate you very much. Thank you so much, my friend. Thank you. Every month, it never fails. It never fails. You decide to come back here every month. I don't know why. I don't know why, but I hope I'm doing something right. Hey, I don't know. Sometimes I think you're wasting on a on a guy like me. But man, I appreciate the constant support. Super nice of you. I don't know what to say, man. I don't know what to say. So you can answer this question here, maybe. Is 0.6505 less than I'm pretty all right. Okay, I appreciate that, my friend. I appreciate that. I try to be somewhat all right. Okay, somewhat. So is is 0.6505 less than 0.10? The answer is no. Okay, good. If the answer is no, what conclusion can we make here? If the answer is no, what's our conclusion? If the answer is no, what do we do? Okay. So we go reject H1 and also do what? Rejecting H1 is nice. What else? The whole thing, JD. Yeah, okay, good. So, yeah, so we're going to accept the null hypothesis and reject the alternate. All right, good stuff. And that's our final answer for that problem. Very good. Nice job. Okay. Excelente. Yeah, are there any questions about that? Any questions, you guys? That is the second example there. So hopefully that again, the process here is pretty easy once you get the step-by-step things here. Is the conclusion statements the same for all tests? No, remember, take a look here very carefully. If it was less than, then you would have reject the null hypothesis and accept the alternate. However, since it was not, we accepted the null hypothesis and rejected the alternate. So note the difference between these two conclusions. We did get one of two final answers here, Planet. Okay, so there are only two final answers here for these questions, Planet. But again, one of these two have to be true. Okay, so when you say the same conclusion here, then it's like, well, that's we get two possible conclusions. You just have to test out the comparison there. Left, right, and two tail. If you're talking about that, yeah, you're gonna do the same test for regardless if it's left, right, or two tail, if that's the question in hand. So if the question at hand says, hey, I get left, right, or two tail, am I still doing less than the level of significance? The answer is yes. You're still doing the same p-value being less than the level of significance. That part is definitely true. Okay. Then exactly what I wasn't sure what you meant there, so okay. Well, all right. If it's the latter, then yeah, then it's still the same test regardless in step 6. That's why I put step 6 as like a generic step. Test doesn't matter because you took care of it when you found the p-value. Okay, cool. Any other questions? Make sure we have all our bases covered. Any other questions? That's fair. Why are you giving me stuff? All right. Any other questions? Otherwise, that is essentially the end of section 10.2. So what that means is that for next time, we're going to finish up chapter 10 here with section 10.3. All right, we'll talk about another type of hypothesis testing. We'll go through the steps there about how to do that, but they'll be fairly similar to the steps that we just talked about here today. So it shouldn't be anything too crazy, to be perfectly honest. All right, so if I'm to assume that there are no more questions here, that's perfectly all right. Go ahead and we'll play a little bit. That's fine. All right. I guess I'll end it off here today if nobody else has anything else to add here. All right. In any case, I want to thank everybody. Let me go and go the other one here. I want to thank everybody here for coming out here to the stream once again. Thank you so very much. All right. Love all of you guys. All right. I really appreciate it. Today was, again, bold green tea here once again. I didn't buy any drinks this weekend, so I'm kind of stuck with what I got right now. I'll be buying some drinks probably tomorrow. So, more than likely tomorrow, because I'll be heading out all over the place tomorrow. So, how did we almost... I don't know. You guys gotta ask. You guys gotta ask. Ladies, you gotta ask, okay? That's just how it rolls, alright? As fine as you like it, there you go. I do. It's good stuff. Oh, man. I will hydrate for you here. I'm pretty thirsty, so... It's pretty dry in my room, so... Alright. In any case, thank you very much, everybody. Okay, again, love you all. Everyone, have yourself a wonderful couple days here. We will be back right same time, same place here on Wednesday, going over section 10.3, ending off chapter 10, and then we'll just have one chapter to do go after that. Alright? Have yourself a wonderful day, and remember, everybody, as always, it's fine. That's fine. Not a problem. That's why we give you a couple days. Alright? Refill the brain. Alright, when is the test? It won't be until after we finish chapter 4 there, Desmond. Okay? Once we finish up chapter 4, then I will announce a test, okay? So that won't be for another week or two. So we'll see exactly what the pacing is going to be, okay? When I announce the test, then it'll go, but it's definitely not this week or probably not next week, so. Alright, so we're just going to run with that. Alright. Chapter 4 is the last chapter here in the textbook. Yeah, we're gonna go from chapter 10 to chapter 4. That's what's next on the agenda there, Planet. Okay. So yeah, we're just kind of working a little bit backwards here, at the end. But chapter 4 is just kind of like it's kind of its own separate dealio. So we put it at the end instead. All right. Confused Pikachu. Remember, it goes chapter 10, chapter 4. You can even look on the syllabus there. That's exactly what it says. Chapter 10, then chapter 4. As simple as that. There we go. Yup. Yeah. I know it sounds weird, but that was the my intention from day one. From day one was go from chapter 10 to chapter 4. I know it seems out of order. It's obviously out of order, but it's kind of chapter 4 its own separate dealio. So no worries, okay? I can guarantee you it's not as bad as it may seem. We forgot to count. Okay. That's okay. All is forgiven. All is forgiven. Don't worry about it. You've done well. You've done well up to this point. All right, don't worry about it. Our first test was over chapters 1, 2, and 3. Then we had 5, 6, 7, and then we had then we have 8, 9, 10, and 4 for our last test. So this one has 4 chapters in it. All right. Well, I'll let you guys figure it out on your own. It's fine. We'll try to do your homework for your other classes. Okay, good. Try to do some homework for your other classes. Try to do some homework for this class as well. In the meantime, though, well, remember, let's not go down procrastination station again, okay? We all know what happened last time there. I don't need to remind you guys, you know. So, like I said, you could go down them tracks. You know, that's fine, but I don't want to see the same results, please. All right. In any case, though, everybody, as I always like to say, I know, JD, I know, but you can't do it to yourself. You can't do it to yourself. You're better than that. You're better than that, okay? You are better than that, and you know it, okay? Responsibility is hard, I understand, but we all love procrastination stations, the best station to stay in, alright? But you can't do it to yourself if it's going to harm your grade, okay? That's why I know you're better than this, okay? I believe in you, alright? You just gotta make the willpower and make it happen. That's it. Alright. Alright, everybody. We will see you Wednesday, alright? And as always, everybody, stay safe, stay healthy, and most importantly, stay sane. Have a great one, everybody. contact me via Discord or email or whatever. And again, if you have questions, I'll be happy to answer them online here after 2. All right. Otherwise, I hope to see you later. All right. I'll see you on Wednesday in the meet if I don't hear from you. All right. Take care, everybody, and we'll see ya. Have a great one. All right. Have a good one, everybody. See ya. Bye.